Designing a deep neural network for a specific task or problem typically involves several documents and artifacts to ensure clarity, documentation, and reproducibility. Here are some of the key documents and items you may need when designing a deep neural network. Pradeep K. Suri. Author and researcher. 1. Problem statement, a clear and detailed description of the problem you are trying to solve with the neural network. This document should outline the objectives, constraints, and any specific requirements related to the task. 2. Data collection and pre-processing plan, a plan for collecting and pre-processing the data that will be used to train and evaluate the neural network. This plan should detail how data will be acquired, cleaned, transformed, and split into training, validation, and test sets. 3. Data dictionary, a document describing the dataset's variables, features, and their meanings. Include information on data types, units of measurement, and any domain-specific knowledge relevant to the features. 4. Data exploration and analysis report, an exploratory data analysis (EDA) report that provides insights into the dataset. This report may include visualizations, statistical summaries, and any patterns or anomalies discovered in the data. 5. Model architecture document, a document specifying the architecture of the neural network. This includes details such as the number of layers, the type of layers, example dense, convolutional, recurrent, activation functions, and any regularization techniques. 6. Hyperparameter tuning plan, a plan for tuning hyperparameters, such as learning rates, batch sizes, and dropout rates. This document should outline the search space for hyperparameters and the strategy for optimization. 7. Model training log, a log or record of the model training process. This includes training loss, validation loss, and metrics over epochs. It helps track the progress of training and any issues that may arise. 8. Model evaluation report, a comprehensive report on the model's performance, including metrics such as accuracy, precision, recall, F1 score. The F1 score is defined as the harmonic mean of precision and recall and is calculated using the following formula. 1 equals 2 precision plus recall F1 equals precision plus recall 2 precision recall, and any domain-specific evaluation criteria. Include results on both the validation and test data sets. 9. Code base, the code base that implements the neural network, including data pre-processing, model architecture, training, and evaluation. Well-documented code with comments and clear organization is essential. 10. Model weights and configurations, store the trained model weights and configurations so that the model can be loaded and used for predictions without retraining. 11. Model deployment plan, if the neural network is intended for deployment in a production environment, document the deployment plan, including infrastructure requirements, API design, and monitoring strategies. 12. Documentation for future users, provide documentation that explains how to use the trained model for predictions. Include example code or scripts for making predictions with new data. 13. Version control, use a version control system, example Git, to track changes in code and documentation over time. This ensures that you can reproduce results and collaborate effectively. 14. Ethical and legal considerations, consider ethical and legal aspects of your work, such as data privacy, bias mitigation, and compliance with relevant regulations. Document how you address these considerations in your work. 15. Project management plan, if working in a team, a project management plan can help coordinate efforts, track progress, and manage deadlines. These documents and artifacts collectively contribute to the design, development, and documentation of a deep neural network project. They also facilitate collaboration, reproducibility, and knowledge sharing within your team and with stakeholders. Thank you.